let's say that you're playing Scrabble, and you have these tiles with letters in them. Let's say that you happen to have these three tiles with the letters A, B, and C. So how many different ways to arrange all three tiles?
6.
Very good, 6. This is a review. So this is just 3 factorial, or 6. And again, we can list this out easily. Okay, good. So we have 3 letters, all the different arrangements are 6. But this is only if all the letters are different. But what happens if one of the letters repeats? Let's say you have 2 A's and a B. So the question is, are there still 6 different arrangements? Okay, so it's gonna be less, but let's talk about what the actual number should be. Let's build up to this. So right now you can't tell the A's apart. But let's say that you could tell the A's apart by like flipping the back of the tile and writing a 1 or a 2 on the back of the tile. So if you could tell the A's apart, then how many different arrangements are there?
6.
Yeah, there's these 6. So if we were to list them out, okay, so this would be the 6 if you could tell the A's apart. But the point is that you actually can't tell the A's apart. So given that you can't tell the A's apart, then this first one would actually be the same as which other one?
The second.
Yeah, these two would actually be the same, and they'd be considered the same possibility. And this third one would be the same as which one? The third, yeah, the next one. And then this one would be the same as this one if you can't tell the A's apart. So we went down from the original 6, if you could tell the duplicates apart, down to only, how many?
3.
Down to 3, corresponding to these 3 unique groups. So the answer here should be, there should be 3 distinct arrangements if you have one letter that repeats. So now the question is, how do you quickly find that without getting the number 3, without having to list them all out like that? So basically the answer that should be 3 represent the 3 groups here, and we can get that by taking the original 6 and dividing by the 2 within each group, and that's how we're getting the 3 groups total. Where does the 6 come from though? What expression gives rise to the 6? Yeah.
3 factorial.
Yeah, the 3 factorial is giving us the 6. If we're assuming that the three letters are all different, then 3 factorial gives us the 6. And then if we divide by the 2 within each group, that's how we're getting the 3 groups. But where do you think the 2 comes from? Yeah, the number of repeating letters, but here it's a coincidence that the A repeats twice. So we happen to be divided by 2, but what if the A had repeated 3 times? Then let's say we have A1, A2, A3B, and that's one distinct possibility, but let's say you have A2, A1, A3B. You still can't tell the A's apart, so these are actually the same the same possibility. Or what if you had A3, A1, A2B, or what if you had A3, A2, A1B? These are all different possibilities among the A's, but because you can't tell the A's apart, they're all the same. So the A is repeating 3 times, but should you be dividing by 3 here, or what should you be dividing by? So how many different ways are there to arrange these 3 A's across these 3 positions?
3 factorial.
Yeah, 3 factorial. So if you list them all out, you'll get 6. And these 6 are actually the same configuration because you can't tell the A's apart. So same thing here. the original 6 here is coming from the 3 factorial, and then we're dividing by the number within each group. So here we happen to have two A's across the first and the second position, and we want to know how many different ways that are to order the A's across those positions. And so this ends up being 2 factorial. And 2 factorial is 2 times 1, which is 2, so you're dividing by 2. But again, the 2 is not necessarily the number of times the A repeats, it's the number of times the A repeats factorial. And that ends up simplifying the 2. So we have 3 factorial total divided by 2 factorial, that's how we're coming up with the 3. So there's 3 distinct ways to arrange these 3 letters if the A repeats a total of 2 times. Okay, so let's build up from this. So what if you had 3 A's and a B? How many distinct configurations of all 4 tiles do you think are possible?
4.
Okay, anybody disagree, agree? Agree. So it turns out this is a small enough number of configurations that we can actually list them out. And then after we list them out, we'll talk about how we can calculate it quickly. So what's another example configuration? Okay.
A, B, A,
B, A.
Okay, anything else?
No.
Yeah, no, and so you notice the only difference in these configurations is where you choose to place the B. And where you choose to place the B, the other remaining positions, the A's just fill those spaces. So basically, all the places you can put the B is either the first position, the second, the third, or the fourth position. And then the remaining spots, the A's get placed there. So there's only 4 unique possibilities in this situation. So how do we calculate this quickly without having to list them all out? So again, yeah?
4 factorial divided by 3 factorial?
Yeah, excellent. So you first imagine that all these are different and you can actually tell the A's apart. If you can tell all these letters apart, then how many configurations of all 4 letters are possible?
4
Yeah, it'd be 4 factorial, just like we did before. But now we have to actually account for the fact that you can actually tell all the A's apart, and they're actually not all different. And so now you have to divide out by the number of ways to arrange all the duplicate A's within each unique group. So in this case, there are 3 A's, and you can arrange all the 3 A's as 3 factorial. So 4 factorial divided by 3 factorial ends up being on top, 24 on top divided by 6 on the bottom, and that's 4. So that's how we're getting this count of 4 distinct configurations quickly. Any questions? Okay, so let's ramp up from here. Now let's say we had this. So now you have 2 repeating letters. The A is repeating as well as the B. And then now you have an extra letter, the C. So what if the same question was being asked? Now you have 6 letters. How many different ways to arrange all 6 letters? Or all 6 Scrabble tiles?
It's 6 factorial divided by 3 factorial times 2 factorial.
Okay,
We
anybody want
had
to
this
add?
on the homework last night before.
Oh, you did? Okay,
Yeah.
okay, good.
Yeah.
Good. Good, so that's exactly it. So let's talk about it. So that's why the homework wasn't due before class like it normally is. There's this one thing that we're talking about now. That's why it's due later tonight. So very good. So this would be, first imagine that these are all different letters, in which case it would be 6 factorial to arrange all 6 letters. But now you have to divide by the number of ways that duplicate letters can be arranged within each unique group. So if you look at only the A's, there are 3 factorial ways to arrange the A's. And if you look at only the B's, there's 2 factorial ways to arrange only the B's. And it turns out that you multiply them down here by the rule of counting. So these are all the ways to arrange the 3 duplicate A's and the 2 duplicate B's within each unique group that you're trying to count. And then the C doesn't repeat at all, but for consistency, what you can do is you can do 1 factorial for the C's. So this part is optional, because multiplying or dividing by 1 doesn't change anything, and 1 factorial is just 1. But it helps to do it for bookkeeping, because you can just count all the numbers before the factorials, and this should count to the total number of letters. Any questions here?
Could we get an example with numbers?
What do you mean with numbers?
I mean, I'm assuming we're gonna do it with numbers eventually, right?
Well, right now, we're just talking about objects that repeat. And the number of objects that repeat are given by these numbers. So we'll do another example. So let's say that you have these Scrabble tiles that spelled out Mississippi. So how many different ways are there to arrange all these letters? So each configuration must consist of all the letters, so how many different configurations are possible?
That's 10 factorial.
Okay, so keep in mind that there are duplicate letters here, so that'll reduce the number of possibilities, just like in this case that we talked about. However, there are duplicate A's, it'll reduce the number of possibilities down.
It would be 7 factorial divided by 4 factorial times 4 factorial times 2 factorial.
So how'd you get the number 7 factorial?
Oh wait, 1, 2, 3.
You just add all the numbers together, right? I mean the letters.
Yeah, you first pretend that
So
they're all
it's-
different.
Oh,
Yeah, so.
First pretend they're all different.
and then 11, not
Yeah,
7.
11 factorial.
Yeah, very good. So if they're all different, then there'd be 11, so just count all of them, so it'd be 11 factorial. That's if they're all different, but because they're not, now you have to divide out the number of ways that you can arrange each of the duplicate letters. So the I repeats how many times?
4.
4. So that'll be 4 factorial to arrange all the I's,
And then 4 factorial.
and then 4 factorial for just the S's.
And then 2.
Yeah. Very good. So this is I, this is S, and then 2 factorial for the P's. And then if you don't want the M to be lonely, you can include that as 1 factorial for the M. And then that's good bookkeeping, because you can add up all the arguments to the factorial, and they should add up to 11. And make sure that you can enter this in your calculator properly. It's easy to make a mistake. Make sure that the 11 factorial is dividing by this entire quantity. So one way to do that is if you use parentheses. So somebody enter it in and let us know what you get. Yeah.
34,650.
34,650. Everybody getting that? Okay. Everybody getting this answer? We can push this in. Okay, good. Any questions? Okay, so now that we talked about this, this is the total number of configurations if you have repeats. Your book calls this permutation with repetition. Remember, when we talked about a permutation, we said that a permutation was you're multiplying by, you're starting with a number, you're multiplying down one at a time, but you could stop before you get all the way down to one. So a permutation is really orderings of a smaller number of things from the total number. But in this case, we're asking how many different orderings where you have to order all the letters together. There's no subsets of orderings here. So this is actually a misnomer. So a permutation implies that you're ordering a smaller subset of the total. But again, here you're ordering the entire number of letters here. So really, this should be called a factorial with a repetition. And so I think this is a misnomer. So if you see this on the book, just be aware of that. So this concept, again, your book calls a permutation with repetition, but don't let that confuse you. Think of it as a factorial with repetition. All right, any questions? So now that we talked about that, let's bring it back to a similar example to the previous examples with the lights, where we were able to use all the concepts for that example. So now let's say that you have 20 lights, but in the previous example, we assumed that all 20 lights were different. But let's say that now some of the lights have duplicates, have repeats. And so let's say in these 20 lights, you have 12 that are red, 6 that are green, and, or let's say 5 that are green, and 3 that are blue. So if you were to put all 20 lights, thread them through an electrical cord, then how many arrangements of all 20 lights are possible? How many different arrangements? So number of different arrangements of all 20 lights. So if these 20 lights were all different, what would the answer be? 20 factorial. So we had already done that case in a previous example. If all 20 lights are different, but now the fact that some of them repeat means that there's going to be less possibilities. That's why we're dividing out. And so this question, even though it involves lights and colors of lights, is actually the same kind of question as this question with the Scrabble tiles. It's just ordering tiles with some duplicates in them. So what would you have to divide by here?
12 factorial times 5 factorial?
Yeah, you divide by the number of ways you can arrange each of the repeating lights. So here it would be 12 factorial divided by 5 factorial, and then divide by 3 factorial.
It's around 7 million.
Alright, so, okay, thanks. Alright, any questions?